We know about parallel lines and perpendicular lines. Parallel lines will stay the same distance apart and extend forever. Now, why forever? It's because technically the definition of a line is that it extends forever in both directions. Now, line segment is, of course, what we're more used to working with, i.e. from point A to point B. A ray is from a point forever. Now, perpendicular lines. Well, we know that they cross at right angles. Well, parallel lines, wait a second. They could meet. How? They could overlap. If they overlap, they're technically the same line, fine. But if you get two lines that are described to you, and you find that they're the same line, there are infinitely many points at which they overlap. This is important for solving problems later on. But for now, we note what happens when you take parallel lines and perpendicular lines and apply them to these slope y-intercept formulas. Why slope y-intercept? It's because it's the most obvious. If two lines have the same slope and the same y-intercept, once you finish simplifying, then they're overlap. They're the same line. If they have the same slope but different y-intercepts, then they are parallel lines. They continue at the same distance apart forever. Now, in theory. In practice, no diagram is forever. Alright, so what happens if we find that these two lines multiplied together, the slopes, end up giving us -1. Why -1 for perpendicular lines? Well, let's think for a second. So suppose we have a bunch of boxes. So if this line goes like this, and this line goes like this, now, first of all, when you rotate this 90 degrees, you go from rise over run equals A over B. Rotate. Rotate. And suddenly, instead of going up by A grids, you're going across by A grids. And instead of going across by B grids, you're going down by B grids. You're going up negative B grids. So the rise would be negative B over, well, run is now A. So A over B times negative B over A, and this is equal to negative AB over AB. This equals -1. So you could do this test, or you can just multiply them together. Now, vertical and horizontal lines are perpendicular, as we can pretty much expect. But we do note that the vertical line, even though you might think the slope is infinity, it is actually undefined, is the term we use. Because dividing by 0 gives you undefined instead of infinite. Now, horizontal lines have a slope of 0. So another reason why it's undefined instead of infinite is because infinite times 0 does not give you -1 in terms of Cartesian coordinate math. Alright, let's do some examples. Here we want a slope-intercept form for the line that passes through the given point and is parallel to the equation given. Here this is equal to y equals 4x minus 2. So the slope is 4 and it passes through this point. Okay, we remember how to do this formula, right? The formula was y minus y1 equals m x minus x1. Now, when we substitute in, we know that m has to equal 4. The slope has to be the same number. And that means y minus, what's y1? 2, equals m, which is 4, x plus 2. Because minus negative 2, well, we can just choose to write plus 2 right here. So, y equals 4x plus 8 plus 2 equals 4x plus 10. All right. So, does this make sense? Well, yes, the slope is the same, and when we evaluate using this number, it works. So, we have the right answer. Is it in the right form? Well, technically speaking, we should leave the y here, even though we're just simplifying by this point. So, slope-intercept form, yep. And here we have another question. Here's 3y plus x equals 3, so 3y equals negative x plus 3. Y equals negative 1/3 x plus 1. Y minus y1 equals m x minus x1. So y minus 4 equals m negative 1/3 times x minus x1, which is 6. Now, y equals negative 1/3 x plus 2 plus 4. So, negative 1/3 x plus 6. Now, does this make sense? Well, does it match up in slope? Yes, it does. Does this work when you plug it in? Well, yes. So, is it in the right form? Yeah. So we proceed. 3x plus y minus 12 equals 0. This gives us y equals negative 3x plus 12. And so we use, once again, y minus y1, x minus x1. So 6 and negative 3 for the slope, x plus 1. So y equals negative 3x minus 3 plus 6 equals negative 3x plus 3. All right. So negative 3x for x equals minus 1 would be 3, and plus 3, yep, 6. Right form as well, so we finish. Now, example 2. Find an equation of the line that has y-intercept of 2 that is parallel to the graph of the line 4x plus 2y minus 8 equals 0. So, 2y equals negative 4x plus 8. Y equals negative 2x plus 4. Well, we need to have a y-intercept of 2. So the y-intercept term is this one. So the desired line is y equals negative 2x plus 2. All right. Example 3. Find an equation of the line that has a y-intercept of negative 1 that is parallel to the graph of the line x minus 3y minus 6 equals 0. Okay, so this gives us 3y equals x minus 6. And therefore y is equal to 1/3 x minus 2. Now, find an equation. That means we can use any of the forms that we want. In this case, it's pretty obvious that the form that we want to use is going to be line is 1/3 x minus 1. So y-intercept of -1 and parallel to the line shown. Alright, an equation in slope-intercept form for the line that passes through the given point and is perpendicular to the graph of each equation. That means that this time we want m2 equals -1 over m1. So, y equals -2/3 x plus 4/3. And what we actually want is -1 over -2/3. And that means we have 3/2. It's actually easier to think of this without actually writing this formula in this case because, well, this gets a little bit awkward when you stack fractions. So, the slope we want is this. We want to go through this point. That means y1 equals mx minus x1. So, y minus -3 equals m, which is going to be 3/2, and then x minus 2. That means y equals 3/2 x minus 3 minus 3 again. Because this moved over becomes, well, +3 minus 3. So, minus 6. Y. Did they state what form they wanted it in? Oh, slope-intercept form. Great. Now, here we have y minus 7x minus 1 equals 0. So y equals +1. m2, 1 over m1, -1/7. Now, y minus y1 equals mx minus x1. So, y minus 4 equals m, which is -1/7, times x minus 6. So y equals -1/7x plus 6/7 plus 4. Now, we're going to end up with y equals -1/7 x plus 4 6/7. Does this make sense for the number we're working with? Well, yes, it passes through this point. And the slope is correct too. Alright, this one. So y equals negative x minus 8. That means m2 equals 1, because the negative inverse of negative 1 is 1. Y minus y1 equals mx minus x1. Now, y1 here is negative 7, and this is equal to m, which is 1. If we want, we can still write it in, times x minus x1, which is negative 8. So x plus 8 minus 7. And y equals then x plus 1. Does this make sense? Well, yes. And it's also perpendicular to this. Okay. So, that's it for this section. Yes, I do realize it's fairly short. For parallels, same slope. Okay, so they run along the same slope forever. And they never meet. Or they always stay together. For perpendicular lines, well, what you need to do is think of rise over run equals a over b. Fine. If we rotate this, then suddenly that becomes negative b over a. So clearly, multiplied together, they need to be negative 1. Therefore, one of them has to be the negative inverse of the other. So we'll see each other again next section.